4. An optician is testing patients for a specific eye condition. It is known from past records that 5% of patients have this eye condition. So past record shows that the probability of the eye condition of the patient is 5%, that is 0.05. Find the probability that from a random sample of 30 patients, so n equal to 30 patients, find the probability exactly one patient. So this distribution is, consider the distribution is binomially distributed 30, 0.05 because n equal to 30. First part of the answer is exactly one patient has eye condition. Exactly one patient. So probability of x equal to 1. We know that in a binomial distribution, probability of x equal to x is NCX p power x 1 minus p power n minus x. This is normally the binomial distribution. Let's replace x equal to 1 and n equal to 30. So 30 Z1, 0.05 the whole power 1 minus 0.05 the whole power 30 minus 1 is 29. With the help of calculator, this answer is 0.3389. This is the first part. The second part is no more than 2 patients. So maximum 2 patients have the eye condition. So consider this probability is no more than 2 patients. So the second part is probability of x less than or equal to 2 because maximum 2 patients, which is equal to, we can use the table, we can choose the value because this table shows the cumulative distribution value n equal to 30 and the first column is the probability value. So here x less than or equal to 2, so the required probability is 0.8122. 0.8122. Part B. The optician claims that the proportion of patients with the eye condition has changed. A random sample of 150 patients is taken, 13 have the eye condition. Using a suitable approximation, carry out an approximate test to investigate the optician's claim. Use 5% level of significance. So our significance level, before that 150 patients, n equal to 150 patients, it is some large value. So this distribution we can convert into a Poisson distribution. In a Poisson distribution, lambda is equal to np. So our n equal to 150, our probability value is 0.05. So lambda equal to 7.5 because n is large, so we are converting as a Poisson distribution. Now y is Poissonly distributed lambda value is 7.5. Okay, now 150 patient is taken and 13 have the eye condition. We have to check whether this 13 is in our critical region. This 13 in our critical region. So where is the critical region? Use the 5% of significance level. So our significance level is also given 5%. Significance level is given 5%, that is 0.05. Now let us check, set the hypothesis. Let us set hypothesis by one-tailed test or two-tailed test. Here the null hypothesis, which is H0 is equal to probability value is 0.05. Then the alternate hypothesis is denoted by H1, which is P not equal to 0.05 because this probability, nothing is mentioned here, less than or greater than or more or less, nothing is given, so we have to consider not equal to. This hypothesis is two-tailed test. We are going to check by two-tailed test. So what is two-tailed test? This two-tailed test we can consider in a normal curve. because our significance level is 0.05. This 0.05 we have to divide it by 2 because two-tailed test. When we are dividing by 2, this value is 0.025. So the first tail, left region and the right region, they are similar. These both are our critical region because two-tailed test 0.025, 0.025. The probability of our critical region must be less than or equal to 0.025. This 0.025 is from our significant level. Let us find the lower tail. Lower tail. Lower tail is the first part of this. This is the lower tail section. So probability of y less than or equal to y. So what is this? Which is equal to? This probability value must be less than or equal to 0.025. It is less than or equal to our significance level. So what is the possible value? Our lambda value is 7.5. Here the possible value is, when you take this value is, so 0.0203. This value must be less than or equal to 0.05. So here the possible y value is 2. Suppose the probability of y must be less than or equal to y, which is equal to, the another value is 0.0591. This is greater than 0.025. But our probability of our critical region must be less than or equal to our significance level. So here the critical region is y must be less than or equal to 2. Let us find out the another critical region, because we have two critical region, lower part and upper tail. So let's find out what is the value of upper tail. By upper tail also we can find out the critical region. The probability of y must be greater than or equal to y, which is equal to 1 minus probability of y must be less than or equal to y minus 1, which is less than or equal to 0.025. This is the significance level. So this value is 1 minus, which is closer to 0.025. So the possible value is lambda is 7.5. So 9, when you choose 9784, this is the possible value. So 0.9784. This subtracted value is 0.0216, which is less than or equal to 0.025. So what is the possible value of y minus 1? This y minus 1 is equal to 13. Y minus 1 equal to 13. So when y minus 1 equal to 13, what is y? Y value is 14. So the required probability is here. Probability of y greater than or equal to 14. So this is our critical region. Let's check the next value. So probability of y must be greater than or equal to y, which is equal to 1 minus. Is there possible to get any of equal value? So 1 minus probability of y less than or equal to y minus 1, which is less than or equal to. So what is the possible value of next value? So here when you 7.5, when you take this values 0.9573, which is corresponds to total. So 0.1 minus 0.9573, this value is 0.0427. It must be greater than 0.025. So this is not our critical region. In this case, the y minus 1 is In this case, y minus 1 is 12. So, y minus 1 equal to 12. So, y equal to 13. Here the probability of y must be greater than or equal to 13. But it is the probability of the critical region must be always less than or equal to our significance level. So this case is our critical region is only here. This is our critical region. Y must be greater than or equal to 14. One of the critical region is y is greater than 4 and another region is y less than or equal to 2. We found two critical region. Now, what is our question? In this case, 13 is not in our critical region. We have to check whether this 13 is possible. So, 13 is not in our critical region. 13 is not in critical region. Hence, we do not reject our null hypothesis, that is reject H0. Hence, we have to insufficient evidence to suggest the proportion of patients with the eye condition has changed. This is our conclusion, has changed.